So we're going to continue with 2.1 linear motion. At the end of this lesson, you should be able to describe the type of linear motion of an object in the following states: stationary, uniform velocity, non-uniform velocity, and also to determine distance and displacement, speed and velocity, and also acceleration and deceleration. First, let's look at linear motion. What does it mean by linear motion? Linear motion, it means a motion that is in a straight line. In this linear motion, we are going to cover a few subtopic ataupun a few content and physical quantity, which are distance, displacement, speed, velocity, and also acceleration. Let's look at distance and displacement first. Distance is a scalar quantity, whereas displacement is a vector quantity. Remember, scalar quantity means a quantity that has only magnitude, whereas vector quantity is a quantity that has both magnitude and direction. Let's look at the proper definition of distance and displacement. Distance is the length of route covered by an object. Displacement would be the shortest distance between the initial position and the final position in a specific direction. Alright, if you look here, this green arrow shows distance from A to B and then to C. What is the distance covered by the boy here? Let's say he is moving from A to B, then to C. The distance would be 700 meter plus 500 meter, and that is equal to 1200 meter. So that is the distance covered by the boy. Okay. Now what about the displacement? Remember, displacement is the shortest distance between the initial position and the final position in a specific direction. In this case, your initial position is here. Your final position is here. So your displacement will be represented by this orange arrow. So that is our displacement. How do we calculate that displacement? Simply using Pythagoras theorem. Alright, which is 700 square plus 500 square, and then you square root it. That would be equal to your displacement, which is 860.2323 meter. Okay. Now let's look at speed and velocity. I'm sure you have heard of these terms in your science and also your math in lower form. Alright, now let's look at the definition. Speed, it means rate of change of distance traveled, whereas velocity would be the rate of change of displacement. Alright, now tell me, which one is a scalar quantity and which one is your vector quantity? Speed is scalar quantity. Right? Our speed is scalar quantity, whereas velocity would be vector quantity. Why? Because if you look at the formula here, speed is rate of change of distance, and distance is also a scalar quantity. And for velocity, it means rate of change of displacement. And we know that displacement is a vector quantity. So velocity would also be a vector quantity. Right? Now, let's look at the formula for speed. Speed would be distance traveled divided by time taken. And velocity is simply displacement divided by time taken. Alright, so let's look at what does it mean by uniform velocity. If you look here, in every 1 second, the car moves by 20 meters. Alright, in another 1 second, the car moves another 20 meters. And in another second, the car is still moving with another 20 meters. In this case, we can say that the car moves with a uniform velocity. Seragam. Halaju seragam. In every 1 second, the car moves 20 meters. So the velocity here would be 20 meters per second. Alright, remember meter per second is the unit for velocity. 20 meters per second, meaning in 1 second, the car will move by 20 meters. Alright, now what if the car, after 4 seconds, what would the distance be? Sorry, what would the displacement be after 4 seconds? After 4 seconds, the car will cover 80 meters. Alright? Now let's look at this example. What does it mean by a non-uniform velocity? If you look here, the first second, the car travels by 20 meters, and the next second, the car travels 30 meters. Alright? Meaning the velocity is not uniform. It moves with an increasing velocity. When this happens, when the car moves with an increasing velocity, we say that the car moves with an acceleration. Pecutan. Maksudnya kereta bergerak semakin laju. Now, let's look at this example. For the first second, the car travels by 30 meters, and for the next second, the car travels by 20 meters. For this one, we also say that the car moves with a non-uniform velocity, and to be exact, the car is moving with a decreasing velocity. When this happens, we say that the car moves with a deceleration. Nyah pecutan. Alright, meaning to say the car is slowing down. Now, let's look at this example here. Abu runs from A to C in 120 seconds. Calculate the speed. Remember, the formula for speed is distance travelled divided by time taken. So to calculate speed, simply plug in the numbers into the formula given. We know that speed is equal to distance divided by time taken. So speed would be 1200 meters divided by 120 seconds. So my speed will be 10 meter per second. Now, what about the velocity? Alright, remember, velocity means rate of change of displacement. The formula would be displacement divided by time taken. Alright, our displacement was 860.23 meter. The time taken is still 120 seconds. So when you plug into the formula for velocity, which is displacement divided by time taken, your answer would be 7.17 meter per second. Alright, remember, speed is a scalar quantity and velocity is a vector quantity. Alright, now let's move on to acceleration. Acceleration means the car is getting faster and faster. Alright, acceleration happens when the car moves with a non-uniform velocity and the velocity is increasing. Alright, if you look here, first second it moves by 20 meter, and then the next second it moves by 30 meter. So now we want to calculate the acceleration. The definition for acceleration is rate of change of velocity. So the formula for acceleration is change of velocity divided by time. Now, when we want to calculate change, meaning you need final velocity and initial velocity. So the formula for acceleration is final velocity minus initial velocity divided by time. Alright, the symbol that we use for acceleration is A. The symbol that we use for final velocity would be V. Initial velocity would be U, and time is T. So the formula for acceleration is V minus U divided by T. Now, what is the unit for acceleration? Alright, what is the unit for velocity class? It is meter per second, and the unit for time is second. So meter per second divided by second, you get meter per second square. So the unit for acceleration is meter per second square. Alright, let's look at these examples. After landing on the runway, a plane slows down so that its velocity reduces from 75 meter per second to 5 meter per second in 20 seconds. What is the acceleration of the plane? When you want to do this type of question, alright, first look at what it wants. It wants you to calculate acceleration. So you know that the formula for acceleration is A equals to V minus U over T. Alright, then our V, our final velocity is 5 meter per second. Our initial velocity is 75 meter per second, and it takes 20 seconds for the velocity to change from 75 meter per second to 5 meter per second. To do this, simply plug in the numbers into the formula. So your A is equal to 5 minus 75 divided by 20. So your acceleration is negative 3.5 meter per second square. Now, what does this negative means? This negative shows deceleration. Alright? You don't have any specific formula for deceleration. To calculate deceleration, we also use A equals to V minus U over T. If you get negative number, it means deceleration. If we get positive number, it means acceleration. Alright, so for today's homework, I want everybody to do an I think map to summarize today's lesson and also to complete formative practice 2.1. That's it for today. Thank you.